Hello everyone! Welcome to our class, Learning Science with Ma'am Leilani D. Samson. For Quarter 1, Week 1, we'll be discussing forces and motion. And with this lesson, we'll investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. Last meeting, we discussed force as the push or pull of an object with a specific magnitude and direction. We've also mentioned balanced forces and unbalanced forces. Let's review balanced and unbalanced forces. Now, balanced forces are forces that are equal in size but opposite in direction. And you can identify balanced forces because they do not cause things to move. Let's look at the example. If there is a box on the floor and you try to push it from one side, but your friend push it from the other side, the box will not move. Therefore, this will be a balanced force. Both you and your friend will be pushing equally hard, so your forces will have an equal size. But you will be pushing on one side, and your friend will be pushing the opposite way. You're pushing in opposite direction. These two forces cancel out and the box will not move, and we can call them balanced forces. In contrast, unbalanced forces are simply any forces that are not balanced. So for example, if you push a box from one side and your friend came to help you, you are now pushing on the same direction. When you push on the box, you will find out that the box will definitely move on the same direction. So this is an example of unbalanced force. Your forces are not canceling out. Here's another example. If you push the box, but your friend came to push on the other side, you're pushing from opposite directions. But we can see your friend is much bigger. He will be able to put down much bigger force than you will. And because your forces have different size, these are unbalanced forces. If you both push, the box will move because your friend is pushing harder. We shall now have the continuation of our lesson. You can pause this part and please take note of the following guide questions. First, who is Isaac Newton? Second, what are the three laws of motion? And third, identify an example applications of the said law. Let's watch the following videos.
There are a lot of things happening in the world. Objects move, fall, and rest all around us. You may think you understand why things move or don't move. But did you know that the forces acting on these objects can be measured and their motion predicted? Renowned English scientist Sir Isaac Newton wanted to understand the world better. He thought he could describe the movements of the universe through mathematical observation. In 1687, he published these observations in a book, which outlined his understanding of the laws of motion. These three laws of motion are still in use today and can help us understand the relationship between a body and the forces acting on it. Newton's first law of motion is often stated as, an object in motion will stay in motion, and an object at rest will stay at rest, unless acted upon by an outside force. This law is also called the law of inertia, since inertia is the tendency of an object to keep doing what it's doing. You have experienced Newton's first law if you have ever used a swing on a playground. In order to start swinging, you have to use a lot of force, but once you get going, it can be hard to stop. Here on Earth, there are some forces working on objects all the time. When you throw a ball upward, it doesn't keep going up forever because the force of gravity pulls it downward. Once it hits the ground, friction, or resistance caused by surfaces rubbing together, will eventually bring it to a stop. Newton's second law says that force is the product of mass times acceleration. Mass is the amount of matter, or stuff, in an object. To make something accelerate or speed up, you have to apply a force. The amount of force it takes to move an object changes depending on how massive it is. Think about it. You would need more force to move a bowling ball than to move a beach ball of the same size. The greater the mass of the object, the more force it will take to accelerate the object, and applying more force will make the object move faster. Newton's third law of motion says that for every action, there is an equal and opposite reaction. If you exert a force on an object, it exerts an equal force back on you. For example, a ball hitting the ground exerts force downward. The floor exerts an equal force upward. This is the principle that allows rockets to launch, or jellyfish to swim. By exerting a force downward, an equal and opposite force pushes upward, and the object accelerates. We can also see the third law in action when birds fly. Their wings press down against the air. The air pushes up against their wings, allowing them to move upwards. Another good example of this law is skateboarding. The skater pushes backwards against the ground with their foot. The ground pushes forward with equal force. Since the wheels of the skateboard reduce the friction between the person and the ground, they are able to move forward for some time before forces slow them down again.
Let us discuss the three laws of motion. The law of inertia. A body at rest will remain at rest, and a body in motion will remain in motion unless acted upon by an external force. The second law of motion, also known as the law of acceleration, and it states that the force acting on an object is equal to the mass of the object times its acceleration. And the third law of motion, the law of interaction, also known as the law of action-reaction. For every action, there is an equal action and opposite reaction. Let's perform activity 3, investigating inertia. For this activity, you will need a glass of water, an index card, and coins. The coin has inertia, meaning it really wants to stay in one place. If you move the card slowly, it isn't fast enough to overcome that force. If you flick it quickly, the coin stays in one place and then drops into the glass. An object at rest will remain at rest. Activity 4. Investigating acceleration. Activity 5. Investigating action-reaction.
Today we're going to demonstrate Newton's third law of motion, which says every action has an equal and opposite reaction. It's the principle that sends rockets to the moon. If you want to try this at home, this is what you need. When I release my fingers, air pushes out of the balloon. That's our action. Our reaction is that the balloon moves with the same force in the opposite direction.
Let's have the recap. Name the 3 laws of motion. Thank you everyone. Until our next lesson.